Hey everyone, so the School of Computing, the undergrads, and the peer mentoring program, we're sponsoring a professor panel. It's kind of like a, if you've heard of Reddit, Ask Me Anything kind of. So there's Joe, Mary Hall, David Johnson, and Cobus Vandermeer. So just be in front of you, sit down, and you guys can ask them any questions you want. Kind of see, learn about their journey into CS, like their background, kind of get to know them. And there'll be free pizza, tons of free pizza. Okay, it's very important. Pizza. Okay, so tomorrow 4:30 p.m. web, 12:30. So it's just upstairs in the web. 4:30. Free pizza. Okay, that's all I have. Thank you.
Hey, Jonathan. Hey, Bruce. Long time no see. Yeah. See you.
Okay, let's get started. All right, so I pushed the PS6 grading test just a half hour ago. So PS6 grades won't be out before the midterm, but you can see the grading test. PS7 has been out since before the weekend. It is due a week from Thursday. You need to work in a pair. Last I looked, only about 6 pairs had signed up. So at least do that, even if you're not starting working. I would like to, everyone that has a partner would register as a pair, and I would know who needs a partner. And there are directions for registering for a pair in the assignment itself. Okay, so the midterm is Thursday, and we'll be back on our usual schedule. Are there any questions or problems about anything? Yeah.
When will the PS6 grading test come out?
Yeah, they came in, they were minus 30 minutes from now, so they're out. Yes?
Is there a curve for the midterm?
Say again?
Is there a curve for the midterm?
Is there a curve for the midterm? Well, there's a curve for the class. So, I don't individually curve the components. Yeah? Well, what we'll have is a review session today, and then in the lab sections tomorrow, the TAs will go over the sample midterm. So if you look on the Canvas schedule this week, you'll find an old midterm, like last year's midterm, and the solutions to the midterm, and these slides here. So we'll talk about the slides today and the midterm tomorrow. Any other questions? Who still needs a partner? I see 4 hands up. 1, 2, 3, 4. That seems like too good to be true. So you're one. There's someone right back there, maybe. Why don't you? And then there were 2 over here. Problem solved. Oh no.
Not me, no.
Okay.
I have a question. Maybe we'll get into it more. But what do you see people fail on a lot in your exams that you wish you could just really drill in beforehand?
Well,
that's big, sorry.
Yeah, I don't have a good feel for 3500. Now 1410, I can tell you what people fail. Don't do any good. I don't know if there is a pattern.
Okay.
Good question, though. Okay, so let's talk about the midterm. So this will be a short review unless you have questions, and I hope you have questions, because I don't want it to be a short review. So what I have is sort of a list of topics we covered, and you can help out by asking questions as we go along. So the details, it's on Thursday. It's not March 2nd, it's March 1st. Anyway, Thursday, March 1st. It covers the first 6 weeks of lecture and lab, so that's through Friday, February 17th. It covers PS1 through PS6. I put a sample of last year's midterm up. You'll see that it's short answer questions. If you write code, it's just small amounts of code, not writing a class or anything. I don't have with patience to grade large amounts of code. You can bring a sheet of notes. So as you study, I recommend you write down stuff you don't want to memorize. As you study, you may decide to watch the videos of the lectures. When you do that, if you find any production problems, in particular I'm looking for places where the sound dropped out, if you would just post a comment on the video so we can check it out, that would be helpful. All right, these are the major topics. So we've sort of switched back and forth. One day we talk about software engineering concepts, and the next day we will be talking about more C# programming language type stuff. And so we've, the assignments have focused on, on the programming stuff, with the assumption that you're practicing the software engineering stuff as you program. But there haven't been any specific assignments on the software engineering concepts, but that has been a major part of the class. So let's just review some of the things we talked about. So at the very beginning of class, I talked about the software crisis, which, as long as I've been a computer scientist, there's been a software crisis. And basically the software crisis is that it's too hard to produce reliable software. Hardware seems to have an easier time on it, but the software lags behind. And that holds true despite the fact that the nature of software has changed completely many times in 50 years. The kinds of software people write, the tools they use, the languages they use, the devices it's written for, all that stuff changes, but it's just really hard to write correct, reliable software. One problem is that techniques for small programs don't scale. So, you take classes and you write 1-week assignments, and after a week you throw away the assignment, and you learn how to do that. But that doesn't necessarily mean that you can go work on an industrial scale project that lasts for months or a year or something. So you sort of have to learn new techniques. And then software engineering as a field is it's not just computer science. It's sort of at the intersection of computer science and management, system engineering, psychology. So it's, the problem of software engineering is the problem of managing a group of people doing a technical software project. So you tell me, what have you learned working, you've been working 5 weeks, PS2 through PS6, on a project that builds, where you can't throw away the parts. What have you learned that's different from what you knew before? What have you taken note of? Yeah?
Time. The amount of time it takes me to fix the last assignment that I did badly eats into all the time for the next assignment, and how it's always a struggle to try and meet deadlines. It's always a struggle to try and do what you want to do in the amount of time. Okay, so she said there's not enough time. It's a struggle to meet deadlines, and the time it takes to fix last week's assignment eats into the time you got to do this week's assignment. Okay? Yeah?
You don't use variable names that are like excruciatingly obvious. You can go back later, try to figure out what you're doing and have no idea. Okay, so I've certainly had that experience, and I imagine many of you have, looking back on code that you wrote not that long ago and wondering, what was I thinking? What did I have in mind when I did this? Yeah. So that's a good point. What else have you noticed? In the back there.
The importance of abstraction and compartmentalization. When you're working on a project, you do one thing, you maybe do specifications, and then when you use those specifications later, you don't think about what was going on inside it. You deal with one thing at a time, and you allow the other things, the code you're working with alongside, to get abstraction. You don't worry about how the spreadsheet works if you're making GUI. You don't worry about how the get cells to recalculate method works if you're making a spreadsheet. You don't have to make that. So
okay. All right, so using abstraction helps you deal with programs as they grow larger and larger. Yeah?
In the past, I tried learning Git on these small weekly assignments, and it just didn't click because there was no larger concept of connecting it all in. When we're doing this project, I'm like, okay, I I get it now. I get it now.
Okay. So yeah, not everyone does, I can tell you, but hopefully a lot of you do. Yeah?
Definitely the importance of unit testing, so when you move forward, you can have more confidence in having written the form, it'll serve you well.
Okay, so the importance of unit testing. How many of you have been surprised, you thought you had a really solid unit, you know, a problem set, and then you get the grading tests and whoops. Yeah, so yeah, I think that's a very common feeling. So yeah, the importance of good unit tests is certainly something I expect most of you have encountered. Anything else? Yeah.
For me, just building like empty unit tests that are going to end up testing it when it does work, and just building the entire skeleton of your whole program before you start. For me, it really helps me understand how all the pieces work together, and at any point I know what's broken and what's not.
Okay, so like test first development.
Yeah.
Okay, you were going to say?
Delete my code sooner.
Delete your code sooner?
Yes, trying to fix something that's buggy and that's not well written and that's not better is going to take me so much more time than just deleting it and rewriting it.
Okay, so she says sometimes it pays off for her to just delete stuff rather than rewrite, rather than try to fix, you know, layer fixes on top of fixes on top of fixes. Yeah?
Blindly going forward takes a lot more time than just planning out what I'm going to do.
Okay.
So for me, coming up with like this step, this step, this step is far more straightforward and easy.
Okay. Okay, so then another thing to point out though is, how would your experience have been different if for PS2 the assignment had been create a spreadsheet? You have 6 weeks to do it. What if I'd given you a 6-week assignment and describe the type of spreadsheet I wanted you to write?
Trying to do it in the last week.
Okay? So I even if I were to give an assignment like that, I know from experience I have to give out weekly benchmarks, or people will just put it off for too long, literally to the last week. But what would you have had to do that you didn't have to do? Because, yeah.
Like, so there were lots of things that I never would have thought of, like a formula evaluation using a stack and like popping off like each different type of token.
Okay.
That like probably would have taken me like 20 or 30 hours to like work through like the algorithm for doing
Okay.
it. But I was just giving it off the bat, so like an hour after completion.
Okay. What else? Yeah.
I never would have thought to like have all the dependencies as their own like, self-contained object. They would have put all the dependencies within themselves.
Okay, so separating out the dependency graph is a separate abstraction. And the first time I used this assignment, I didn't do that. I think, I have vague memories, but I think I basically did they did the formula class, and then we sort of moved straight to the spreadsheet. And what I observed was the students have a lot of trouble dealing with dependencies. Yeah?
Testing would have been a lot more difficult because the few gotchas that we had along the way, we had the grading tests as a backup for the next week, so we would have like carried on with those mistakes without any sort of check.
That's true, and the longer mistakes fester, the harder they are to fix. So you sort of got the 1 week cycle in finding bugs. Yeah?
It would have been impossible for TAs to help because everybody would have gone on their own routes.
Yeah, that's true. It would be really tough on the TAs. Yeah?
Seeing how you gave the assignment as like, do this first, do this next, was instructional and like, this is how we should be thinking about how to build something if we're trying to build it and we don't know how to do that on our own.
Right. So eventually, if you're not already there, you want to get to the point where you could take a problem like this and break it into the pieces. It was a little artificial that I was doing that for you, but you know, when you're working in a group and you've got leaders and say a lead programmer, that experience can be like that. Someone has to break it up into bits, and it takes time and experience to learn good ways to do that. So anyway, you've experienced you know, a lot of the issues in software engineering here in a controlled fashion. You weren't exactly thrown to the wolves, but you know, it's a sizable project, and I understand the pressure builds. But like I was telling you at the end of class last time, this is about the point where pressure, it starts to get easier from this point forward. because you're working with partner and for various reasons, as you'll see as we go on. Okay, so the software lifecycle, traditional one, starts with analysis, which is figuring out what it is you want to build. Design, which is breaking it up into pieces. Coding, testing, and then maintenance. So where have you spent your time?
Coding.
You've certainly done a lot of coding. Okay, you've done testing. You've had to write unit tests. And you've done maintenance. Every time the unit tests come out, I mean, it is, let me ask the TAs, how common is it that someone passes all the grading tests?
Very rare.
Like once?
One, like every 2 weeks.
Okay. Okay. So it's rare to have a perfect assignment. I mean, there are a number that are up high, but passing every unit test. And so you spend most of your time in coding, design, and maintenance. I mean, coding, testing, and maintenance. It says here, you know, in a real project, the majority of the time is spent in maintenance. You know, that's counting really after the program is released and you gotta, you know, keep fixing things in it. But for you, maintenance would be everything you do, let's say, after you submit it for grading. So, did this hold true? Do you think you spent the majority of your time in maintenance? I'm seeing some people say yeah. Maybe some people say no. I mean, we've tried in the past. We would ask every week for people to say, to tell us how many hours they spent on each. You know, we'd give them some categories and ask them to tell us their time. But what we found out was that students were worried they were being graded on it, and so they would just make up numbers that they thought we wanted to see. So we didn't get any useful data that way, and I stopped asking. It would be, if I could somehow, without your knowledge, instrument your computer so I could tell how you spent your time. But, yeah, that's not ethical. All right, so here's the software engineering concept, version control. And it's good for backing up, for recording modification histories, to make it easy to use multiple machines, for coordinating multiple programmers. You know, you can do things like commit, branch, merge, clone, so forth. And of course, we've been using Git. Some of you use it from the command line, which really, you know, when I use it from the command line, it's not, my problem isn't using the command line, it's just remembering the commands. But it's pretty easy to use there. And as far as it goes, it's easy to use the one in Visual Studio until something goes wrong, and then it's kind of hard to figure out what's going wrong. What's your experience been using Git? Has it been an annoyance, benefit, a burden? Yeah?
It's been great, except for when it doesn't work.
Except when okay, so when hasn't it worked? What's been a...
Well, like last week when everyone was like, I can't push, and like for some people, like updating worked, and for other people, they just had to like brute force command line it.
Right, so that, I'm still not sure. Someone said it has something to do with Visual Basic. Was that the consensus? Maybe some update to Visual Basic was pushed out somehow, and somehow it compromised the Git plugin? I don't know. Yeah?
So I did a little research because I was doing some stuff for my job. I was doing it too. So it was, I think it was Git, the GitHub backend, like updated their security protocol or something like that.
Oh.
You either had to reinstall Git or update Visual Studio to, I guess.
Okay. Yeah. So yeah, so I agree that was kind of bad. It happened the day the thing was viewed. Yeah.
I found what's frustrating about Git is it automatically writes over your files for you. When you switch branches, it goes through the file system and writes over what you have there to match the branch you're on.
Right.
And then you switch branches back, it writes over the other way. I think that might take memory, but I suspect that memory is not that big of an issue in large development environments.
Well, I don't
just restricts access to work you've done, or to even erase work you've done.
Well, it doesn't erase work you've done. It won't let you check out something new, i.e. overwrite your old stuff unless you've committed the changes. So it's not erasing, it's still in the commits. But yeah, I mean, that's just the way it works, is you work on one branch at a time. And that's, yeah?
I've heard of software development companies having like a guy who knows Git really well, and he's like super useful. So I was excited to learn about Git because it's something that
Right.
is
You can
really
be
practical.
super useful. That's a good thing. And the problem I have, the problem that I see students have, is Git is fine until the day comes when they want to, they've messed up and they want to go back a couple commits and start from there. Or they've got to do a merge for the first time. So anytime you've got to do something for the first time in Git, you know, there's a learning curve. And if it's under the pressure of a deadline, you know, then it makes it doubly hard. So once you learn it, it's great. While you're learning it, it can certainly be frustrating. You know, when you don't have a complete model of how it works, then you can be confounded by things. Have any of you been saved by Git?
Yep.
I mean, have you, any of you reverted back? Some of you have. Okay. Testing. We talked a lot about testing. Clearly, it's a key part of the software development process. You know, a lot of times in our classes, you know, students in classes tend to view testing as sort of an afterthought. It's the last thing you do, as opposed to the first thing you need to think about. I emphasize the need to understand that the goal of testing, when you're writing tests, the goal is to break the program. The goal is to find errors. And so if you've got 2 hours to devote to writing tests, you need to spend those 2 hours designing useful tests, ones that are most likely to expose faults. I think with all the experience you've had in all your classes, you probably agree that tests have to be easy to run or you won't bother doing it. It's certainly nice to be able to push a button and get all your tests run. We've done primarily unit testing. Well, completely. We've done nothing but unit testing. Now you're still, even when you did your spreadsheet class, you're doing unit tests on the spreadsheet, even though you've integrated some of the, the formula and dependency class in. You'll be doing, when you sort of test your GUIs, just by using them, that'll be a form of integration testing or UI testing. And it's easy to ask questions on exams like, what's the difference between black box and white box? Black box is the kinds of tests you can write only knowing the specification. And white box are the kind of tests that you can write knowing the specification and details of the implementation. Okay? What's been your experience with testing? Yeah?
More recently, I've had Stack Overflow and out-of-memory issues where I can run about 10 tests just fine before they crash, but if I run each test individually, they run just fine. I just can't bulk run any of my tests.
Okay. I heard from one student that had that, like they failed most of the tests when they, this is for the spreadsheet, failed most of the tests when they ran them with the click of the button and passed them all when they ran them each individually. What was the problem? Yeah? Static variables instead of instance variables. So essentially there was only one spreadsheet possible. You could call lots of constructors, but every instance shared the same static variable. And so when you ran them with the click of the button, it was within one instance of C#, and so the different test cases interfering with each other that way. Yeah?
What is integration exactly? Integration testing?
It's just, it's not clear exactly when unit testing turns into integration testing, but it's when you combine different subsystems into something more complicated and test the whole. Okay? Yeah?
I've actually been surprised how much I learned about coding from trying to write tests. Because, for example, it took me like 20 minutes to figure out how to make sure that the formula, like using R equals or is true or anything, because I'm using structs, and so they're technically never equal. So just developing, like we talk about writing tests in advance, but it's really hard for me to do because I always seem to misunderstand how to use the tests.
Okay. Yeah?
I really like tests because I can notice something in my code and say, oh, I think I can change this thing, and then I can rerun my test and say, oh yeah, I didn't break it.
Right. Yeah, it is nice to have that backup of regression testing when you change something. Yeah?
I think the 80-20 rule holds pretty strong, where like 20% of my code causes 80% of the problems, and then 80% of code causes 20% of the problems. So I have big things that cause big errors and so forth. Right, and it's also true that that 20% then has a good chance of getting worse as you're fixing bugs unless you're careful. You know, it's easy to take bad code and make it even worse. Yeah?
I have an interesting case where I think this was assignment 6. I wrote the ability to save and load classes and then began writing tests for them. I would prefer to write the test first, but if I'm running out of time, I usually don't. And what happened is, as I was doing it, every test I threw at it, my code would pass, even though it was only my first attempt at writing the code, and I hadn't made any modifications to it. And it was making me nervous because it didn't seem to make sense to me that I would get it perfectly right on my first try. It kept thinking that there must be something I was going to find, but I couldn't. And I don't know if there's a name for that uncanny feeling, but I passed every edge case test I could think of. And so
Really?
I moved on, but it was weird because I usually write a code. It looks like it'll work to me, but I assume that it won't work until after I worked out all the issues using my test.
Okay, well that's a good problem to have, I guess. Code worked the first time. Okay, we talked about debugging, and I'm sure you got plenty of experience with debugging. And what I encouraged you to use was a scientific approach, rather than sort of a panic approach of just trying anything you could think of to uncover the bug. Is to try to think of an explanation, design an experiment to see whether your explanation is right, and refine it, so using a scientific method. Did any of you feel like you got better at debugging? Okay. So what do you think that is? Was it practice? Was it a different mindset? Yeah?
I just feel like the more you do it, the more bugs you find. Like, you get a better feel for what's causing it, and like the kind of bugs that you specifically write. So you can like go, oh, okay, I think I know what's going on here. Debug in a second, go, yeah, I'm right, fix it, and then move on.
Okay. So certainly experience pays. Yeah.
I think for me, just being able to set like, the stopping point, the value that I'm looking for is a lot more helpful than just continually going through until I get there.
Okay, so like a conditional breakpoint. Okay, so that's getting more familiar with tools, yeah?
And yeah, just becoming more familiar with programming. As I go into the debugger, then I kind of understand what I'm looking at better.
Right.
I'm understanding what's, oh, okay, so that's causing that, and oh, okay, so that's
Yeah?
I've been amazed at how many times I walk away within like 3 minutes. I have what I needed and I go back and fix it, and it's like I was going to take a break. I was going to like stop for like half an hour, and then it was like, no, I have to do this. I have to fix it now that I know how.
Okay, so yeah, so if you didn't hear her, she was amazed how many times she walked away and almost immediately realized what the problem was. Hard part's walking away. Yeah.
In that same vein, basically, I take an idea of I'm debugging it. I find a problem. I give myself like 10 minutes or so. And if I haven't like at least identified a weird section of code where I know a bug is somewhere in there, I stop and I like just reevaluate what it really is instead of just trying to brute force it.
Right. Okay. Yeah.
I found that the time that I spend writing unit tests will usually pay off 2 or 3 times over with debugging everything, especially the earlier in the writing.
I can believe that. Yeah.
I feel like I've gotten a lot more comfortable with the debugger just watching TAs debug my code.
Yeah, and it may be that the people in the class that have gotten the most better at debugging are the TAs. Because if it's hard to debug your own code, it's really hard to debug someone else's. Because you really are starting from scratch. You get better at debugging?
Yeah.
Okay. I don't know what to say about this. I mean, I've stressed the need for good commenting, and it certainly can pay off when you're going back and looking at old code. So this just describes the type of comments that I like to see. Basically every, classes, methods, properties, instance variables, only different sorts of comments. So those were sort of software engineering concepts or habits or what have you. We also looked at software engineering tools. You won't always be using Visual Studio. You know, you may be using Eclipse or IntelliJ or Visual Studio or on and on and on. There's lots of different programming environments you can find yourself working in. But you know, any tool you use is going to provide various kinds of support, like organizing your projects, editing support, color highlighting, formatting, and all that, documentation support, and of course Google is indispensable for researching things. You've just all sort of grown up taking all this for granted. But I can remember the first time I used an editor that auto-indented the code, or that color highlighted the code, or that popped up IntelliSense, and all that stuff. It was just earth-shaking. You didn't have to go pull the manual off the shelf and read through it. Because I can also remember programming before there was an internet, or not before there was an internet, before there was a web. And believe me, the experience has changed a lot. Yeah.
You get a sense of how to do this every time you take a test, though, right?
That's true. You take a test from me anyway. I get that complaint a lot, that in 1410 especially, that I'm asking people to write programs and they've never done it on paper before. So yeah, that's sort of what it gives you an idea. Okay, version control. I think any time you put into learning Git is well spent. The better you can get at that, the easier things are going forward. So, ideally, your experience wouldn't be limited to using the plugin. Once you get an idea for what operations are possible in Git and when you use them, that's a good time to start experimenting with the command line. You can install the command line code directly from VS. At first, it's always bugging you every time you start it up. You want to install the Git command line tools, and then you can run the shell from Visual Studio, and it'll open up in the same folder as the repository. And then it's just a matter of saying something like git push origin or something, and that pushes it up. So you can learn pretty quickly how to work from the command line. But we already talked about Visual Studio support for debugging, and Visual Studio testing tools and profiling tools. I don't know if any of you had the opportunity to use, or the reason to use profiling tools outside of the lab we did. Anyone ever want to speed code up? I know at 4150, which I'm teaching right now, I give them a weekly programming problem that they have to complete on Caddis, which is a programming contest website. And all those, essentially solving one of those problems involves taking an algorithm we've been talking about and adapting it to the problem of the week. And there's a time limit. And so that's a place, if you're up against the time limit, not quite passing it, that those students certainly make use of profiling to figure out where their time is being spent. Let's take a break here. We'll take a few minutes off and then we'll continue with this. Okay, let's get started. All right. So far, we've been talking about software architecture some. In that first assignment, we used a pipe and filter architecture, sort of a classic, 1970s, 1980s kind of deal where you have a program that reads from standard input and writes to standard output in a way that's designed that you can cascade them by piping them together at the operating system level, making use of command line arguments. And that's good, and it's good you have that experience. But then I find that I teach a class like 4150, like I mentioned, they're writing CAVAS problems, writing problems for the CAVAS system. And all those programs have to be designed as filters. They read their input from the command line, or not from the command line, they read their input from standard in, and they write to standard out. And it's judged on what they write out. And the students there act like they've never seen something like this before. So I just ask, when you take 4150, you try to connect what you're doing there with what we did in here. It may be that, I know in the fall offering of 4150, they don't even have that first assignment. So maybe they're the ones that are struggling at first in 4150. But it's good to know classic architectures. What we've been doing lately, I just call the classical object-oriented software architecture. The formula class, the dependency graph class, the spreadsheet class, where we're representing new types of data with classes and making representations private and trying to have code reuse by using inheritance and interfaces and such. Okay. Has what we've done opened your eyes at all to ways of organizing programs? Seen it all before. Okay. And we'll be looking at other programming architectures going forward, software architectures going forward, like you'll be working with MVC, with the GUI architecture, this next assignment. And then you'll be looking at client-server using REST calls for 3 assignments. We'll be doing database programming. So you'll get your experience with a lot of those. We've looked at C#. A lot of C# I didn't have to say anything about because it's just similar to any other language you've used. There were some things that were novel. So C# uses the .NET architecture, which essentially means when you compile C#, it compiles to code that runs on the common language runtime. And that means that it can compiled C# programs can interoperate with other languages that are compiled to the same runtime. We talked about dynamic versus static linking, and essentially C# .NET is using dynamic linking. It produces dynamic DLL files that can be shipped around and used in programs, even though they can't be directly run by themselves. You learn the technique of certainly of programming to a specification. A couple things that you had to get used to were iteration abstraction, so the idea of using yield return to enumerate a set without explicitly building it, a collection without explicitly building it. Yeah?
Is there a downside to using yield return? It seems very powerful.
There's no downside to using it as long as what you want is, an IEnumerable, which is basically a collection that you're limited to what you can do with it. You can essentially iterate through it. If all you need to do is have a collection you can iterate through, that's great. And some things become a lot easier, actually. Yeah?
Why don't we use statically linked libraries as opposed to dynamically?
I don't know that you would use statically linked libraries in .NET. I know that, on old Unix system, and I suppose Linux systems, there were options. When you compiled stuff together, you could statically link in some of the libraries. You could choose whether to do static linking or dynamic linking. I think I usually do ask some sort of question that involves yield return on the midterm. So it's good to know what's up with that. you have any questions, it'd be a good time to ask. Yeah?
What is CLR?
What is what?
What is CLR?
Common Language Runtime.
Okay.
It's sort of the equivalent of, say, the Java virtual machine.
And like, how detailed do we need to know about these?
Well, you know, I guess it's important, you know, just like Java and C# have this property, they're compiled languages, but they're not compiled to machine code. They're compiled to abstract assembly languages that run on virtual machines. So just knowing that, I'm not going to ask you to define CLR. Knowing the difference between an exe, an executable file, and a dynamically linked library. I mean, some of your projects, in fact, since PS1, all these subsequent PSs, PS2 through 6, have produced DLLs as their product. You actually will be building an executable when you build your actual spreadsheet. So, you know, knowing the difference between static and dynamic linking. And then, knowing enough how to write simple methods that use yield return. Good to know. You've gotten a lot of exercise using delegates, and you'll continue. They show up more and more as you get into client-server programming or accessing the web, multi-threaded programming. We talked about tasks a little bit. You didn't get any programming experience with it yet, but you need to understand the basic idea behind tasks. Multiple things running at the same time and what issues can occur. And we recently have talked about events. So speaking of tasks, it's an approach to concurrent programming. There are other approaches. It's been a heavily researched thing for the last few decades, trying to find ways to make it possible for people to do multi-threaded programming, concurrent programming, because it's hard enough to write a singly threaded program. When you've got to worry about interactions among multiple threads, it rapidly becomes too complex for people to think about. And so there's been this search on for good abstractions to hand the programmers so they got a fighting chance. When you got multi-threading, you've got the possibility of two threads, two tasks, simultaneously having access to the same object in the heap. And when that's the case, you've got to worry about synchronization. And so you need to know that's what locking is for. That you use a lock to prevent more than one thread from accessing a chunk of code at once. I don't think we talked about waiting in this, so you can scratch that. Just remember that if you have a multi-threaded program, a multi-task program, how many stacks do you have? How many runtime stacks in a multi-threaded program?
As many as you have threads.
Right, one per thread. So if you've got 10 things going on at the same time, you've got 10 tasks. Even when task suspends, even if it's not running on the core, it's waiting for its chance. There's still a stack stored somewhere, ready to be used again when the task runs again. How many copies of the code do you need? You've got 10 tasks. Now, just one, because it's read-only, so you can share access to the code base. Heap, how many heaps do you have? One, and that's how sharing is accomplished. Sharing between threads is accomplished via the heap. So if you could not share any memory between threads, you wouldn't, it'd make your life simpler, but there's not many concurrent programs you can write that don't need to cooperate to some fashion. Right? What's a critical section? Yeah?
Point to code where one thread could override or interfere.
Okay.
Execution of another thread.
All right, so it's a piece of code where you worry about multiple threads executing in there and interfering with each other. And so usually a critical section is a section you protect with a lock. Keep out multiple threads. I didn't demonstrate a deadlock, but a deadlock occurs. Imagine if you have multiple critical sections in your program and you have one thread that holds lock A and is waiting to acquire lock B, and another thread that holds lock B and is waiting to acquire lock A. So neither can make progress until one of them gives up and releases the lock that it holds. That's called a deadlock, and that's a bad thing. So when you're programming concurrent programming, when you're doing concurrent programming, you want to write your programs in such a way that you avoid the possibility of deadlock, and failing that, have some way of detecting a deadlock has occurred and have a way to back up, abort. That happens a lot in databases. So anyway, right now it's just a purely theoretical knowledge of threads and tasks. We'll be looking at it in more detail in the back half of the course. Something that I left out that I should add, maybe you could help me out here. What other newish sort of programming techniques have we talked about first 6 weeks of the course? Can you think of any aspects of C# that you've never used in another language? Yeah?
Lambdas.
Okay, sure, lambdas. They sort of go along with, often used where delegates are needed, but yes, lambdas. Yeah?
Properties.
Okay. So properties as an alternative to getters and setters. Yeah?
Definitely the dynamic type and extendo operator.
Yeah, I'll leave that off because that was after week 6. But, yeah, that's clearly important for the second half of the course. Yeah?
Structure.
Okay, that's right. I left a lot of stuff off. So structs. Yeah?
Passing by reference.
Okay. Another room here. I think it's on the next slide, but ref and out parameters. What else can you think of that we could add here? Yeah?
You mentioned earlier agile and software, the concept of agile.
Yeah, I wouldn't really fit on this slide, but yeah. So back when I was talking about the traditional, the division of analysis, design, code, testing, maintenance. In that part of the course, I also talked about there's a traditional waterfall approach, which says you spend months, if not a year, on each step. So you got to get the analysis perfect before you do the design. You got to get that all perfect before you do the implementation, and then you got to get that right before you do the testing, or the debugging, the maintenance, whatever. Agile processes are more like you spend a week or two. Every week or two, you iterate through all 5 steps. So the system evolves as opposed to being monolithically designed. That hasn't been a major focus of the course. What else on this list about programming techniques?
We use command line, and we haven't really had to use that a lot with our programming.
Okay,
and we actually
command
had to
line.
use that a little bit with the Python filter.
Right, command line, I guess that was sort of covered on the slide that talked about the pipe and filter. Yeah?
Regular expression.
Okay, yeah, that's the one that I thought about originally. That's why I started editing the slide. So I'll put command line in here for completeness.
And if we had troubles with Git, then we were also using command line.
Yep, that's true. And then regexes. I mean, I'll admit, from my personal experience, there's a lot of times when I should use a regex in a program and I don't. Why do you suppose I don't do it? I have to look it up. Right? I don't do it often. I don't need them often enough to, and I use enough languages that I never can remember exactly how to use it. And in the heat of the moment, it just seems simpler to do some loop, looking at the characters and making sure everything's in the right order. So, but I do. It is really worth it to get good at regexes. The opportunity to use them comes up all the time. Okay. All right, we just talked about that. Okay, so it's good to know in C# how you create namespaces. So every program you write, every class class, every file that you write, the stuff you're writing is inside of a namespace. And you probably haven't thought much about namespaces, except when what happens? You get an error message that says it can't find this namespace. Now, what causes that? That you can't, when you can't find a namespace, besides misspelling the name of the namespace? Yeah?
The references are off.
Okay, that's often a sign that you're using a DLL, but you don't have a reference to the DLL. So, assuming you've got the DLL laying around, you need to add the reference. It can also occur when, if you had this experience, you want to use something from the C# library, you don't know what it is, you Google it, and you find the class you're supposed to use that does the trick. And so you go to use the class, and you even import the namespace it says to import, and it still doesn't work. Does that happen to anybody? So what's the problem there? Yeah?
I guess for me, I realized I was trying to import interface, and that just doesn't work at all.
Okay. So, yeah?
Your example, was the code that you downloaded dependent on other code that you should have downloaded?
Well, it wasn't that downloaded code. It was that I saw a class I wanted to use, and I just started using it in my code. You know, it's from the .NET library. So the answer is, by default, when you create a C# class file in VS, it doesn't import every possible thing. It doesn't use every possible namespace from the .NET library. Okay? And furthermore, it's possible for you to use a namespace for which, even though there's a DLL in the library that has this class defined, it may not be available inside Visual Studio at the moment. You have to take the extra step of going out and pulling it in, installing it basically. So sometimes there's an extra step where you've got to update your, I'm not sure exactly what you're updating, but you have to go get that DLL and at least make it accessible to your program. It's not a big step, but it happens. Okay, so there are namespaces. First methods you implemented were static. You need to know the difference between classes and structs. So what's the difference? What's the difference between an object of a class versus a struct of a struct? For lack of a better term, yeah?
Structs are value types.
Okay. Structs are value types like ints, bools, doubles, and objects are reference types. What does that mean? What's the difference between a value type and a reference type? Yeah?
I'm still kind of struggling with this, but the key difference I have in my head that seems to hold true is structs stay on the stack, and classes you reference something in the heap.
Well, that's a little inaccurate in that a struct can be on the heap. Okay? So what's the better distinction? Yeah?
A struct generally should be immutable, so you're copying it.
Okay, so that's a different sort of thing. Structs are best immutable because a number of you, I think I gave you some bad advice and suggested you might want to use a struct as your cell to represent your cells in the spreadsheet. And then I got lots of people having problems, and I regretted saying that. What was the issue of using a struct to represent a cell in a spreadsheet? Yeah?
Structs are passed by values, so you can just like...
Okay, so when you pass, let's say you want to change the value field of your cell, right? You reevaluate, you want to store a new value in it. So you go to your dictionary, you pull out the struct you want to change, you set the value property, and what happens? Nothing. You've modified a copy. You have not changed what was in the dictionary. And so to make this work, you have to then turn around and store that struct back into the dictionary. So mutability, i.e. the ability to change properties, instance variables in a struct, it's a bad combination with a struct. If it's mutable, you probably want to use a class. So I think I take it back. So it would have been better a class. I think a lot of you reached that conclusion on your own. But we're still back to what's the difference between a reference type and a value type? Yeah?
Structs are created in place on the stack.
Okay, well, I was with you until you said on the stack. Structs.
Where they all.
Structs are created in place. Class objects are always stored at an indirect, via an indirection. So let's just look at a picture here. It's good to have this picture in mind. So if I say foo f equals new foo. All right, clearly, somewhere on the stack there's a place to store f. All right? If foo is a class, how will this new object be stored? It'll be stored out here on the heap, and there'll be a reference to it. So it's always stored indirectly. On the other hand, what if it's a struct? It's just stored right here, where the reference would be if it were a class. So it's stored in place. Yeah.
So what about like some kind of reference type inside of the struct? Would that still reference to something on the heap?
Sure. If the struct contains, let's say it contains several properties, and one of them is a reference type. Okay? So what's stored in the struct, in that property, is a reference to something on the heap. Yeah. The other thing is, suppose an object, let me get rid of this and make a rectangular object. Suppose it has a property which is a struct. Where would the struct be stored? Yeah?
Within that object.
Right here. It would just be stored in place. Now suppose it has a property that is an object. It would be stored at a level of indirection. So it's wrong, the reason it's wrong to say structs are stored on the stack is they're not. It can be stored there. The point is they're stored in place. And objects are stored via a reference. There's always a reference stored to somewhere else. So that means that you can have two references to the same object. So when you pass objects around, you're just passing the references. When you pass structs around, you're copying the structs. So if we pass this struct here as a parameter and modify it, well, it's been modified in that method. It's unchanged here because it's a different copy. It's assuming we're not using call by reference, which is confounds things a little bit further. Yeah?
Can you have a nested or inner class inside of a struct?
I don't know. Who knows? Can you have a nested class inside of a struct? Or a nested struct inside of a struct? I don't know. Have to try that and find out. Okay. So back to this list. All right. Classes and structs. You know how to define properties. So it's a nice improvement over having to write getters and or setters. It can be overused. Not every instance variable ought to be a property. What about parameters? I say in, out, ref. There's no such thing as in. It's just, I guess I use that word as alternative to out. Yeah.
I was just going to actually ask a clarification on the in. I've seen it in the code somewhere, like it'll say like in like a generic type parameter. So I saw it there, I'm wondering.
You saw an in parameter in C#?
Yeah, I've seen the word in being used.
Oh, there's the keyword in and for each.
Right.
That's just where Java uses a colon. C# uses an in. I think that's, I don't know why I said in. I'll just say regular. Now that sounds like regular expression. Ordinary. Okay? So what's the distinction? They're sort of just passing parameters. Then there's passing them when they're labeled as out, and passing them when they're labeled as ref. It's really easy to make up problems like that for midterms. So, I expect there will be one. What is the usual method of passing parameters?
Specify what type you want it to be and give it a variable name?
Well, yeah, I mean, okay, so you write it, you just pay, you're just calling a method like you're saying f of a. Okay? How is, let's say a is right here, and a is an object. What happens So you're passing it to the method f. So up here there's some method f that's expecting x as a parameter. What happens when you call by just regular parameter passing? Yeah.
You're passing a copy of the reference.
Right. You copy whatever is in this box here. So if it is a reference, you just copy the reference up here. If, on the other hand, this were a struct, you would copy the struct up. That's just regular old call by value. What I was trying to call an end parameter and shouldn't have. So ordinary parameter passing. Now, how's that different when you pass by ref or use either a ref or an out parameter? So same deal, except now you're saying out A or ref A. Yeah.
Is out A by itself, like just having the one, does that work?
Yeah. Yeah, you can pass one out parameter. And as far as how the parameter passing operates, out and ref are the same. There's a difference, but it shows up in a different place. So what's it look like to pass this A right here by reference? So up here is our X. You know, it's in a different stack frame. Yeah?
So instead of copying whatever's in the box A, X will instead point to wherever box A is located.
Right. X will now sort of have a pointer. It'll have the address of A down here. So anytime it needs to operate on X, it'll instead operate on that box there. And that's whether you pass it ref or out. Okay? So one thing, why would you pass something by reference? Yeah?
Because you implemented yourself as a struct.
Okay. Right? So you pass things, but you would pass a struct by reference because you don't want to copy it. Right? You want to pass a reference to the place it's stored as opposed to copying it. That's a good answer. Yeah?
You want to return multiple things.
Okay. Another reason to use ref and out parameters is you want to return more than one result. One way to do it is to pass them back in an out parameter. You might pass something by reference because you want to avoid copying something huge. You got a huge struct you don't want to copy. Okay? But no matter what you're passing, what ends up being passed is the address of the thing you were trying to pass as a parameter. All right, now what's the difference between ref and out? I've been talking about how they're similar. Yeah?
Out outputs to a variable, or ref uses an existing variable.
No, they both use existing variables. Yeah?
I believe when you use out, let's say you're inside the method, it requires you to assign to it.
Okay, so an out parameter comes with restrictions. If you pass a parameter, if you pass an out parameter, the method you're calling cannot use the incoming value of the parameter. Furthermore, before it returns, it has to give that parameter a new value. Okay? With the ref, there's no such restrictions. You can use the incoming value, and you don't have to change it if you don't want to. So you can pass an uninitialized variable if you pass it out as an out variable. You can't pass an uninitialized variable as a ref. Yeah?
Is that kind of how, like, you can't modify like a linked list during a for each?
Well, it's similar in that it's a restriction on what you can do with the thing, but it's different reasons.
It can't change though. Is what I'm getting at.
Yes, but it's for different reasons.
That's the only difference.
Between out and ref?
Yeah.
Yeah, the difference between out and ref is what I said. The called method can't use the incoming value. There may not even be one if it's an out, and it has to assign to it before it returns. So out is typically a way to get multiple return values back. And ref is a way to, well, it's just more flexible. You can do other things with ref. Okay. Present. Okay, let's see what else is on this list. Use inheritance and interfaces. Well, you've gotten plenty of experience using inheritance and interfaces. Some experience using inheritance and interfaces. It's not, you know, if you've used Java, it's sort of the same idea, identical idea, just different keywords. Create, consume IEnumerables. That's a question. Okay.
Just about interfaces and C#. I have a lot of experience with Java, and I'm wondering, it seems like in Java there's a way to be like bounded wildcards. Is there anything similar to that in C#? Or wildcard types?
Yeah, there are similar things, but I have very little experience with them, so I can't say much more than that, or anything more than that. Create, consume IEnumerables. All right, so if you're supposed to return an IEnumerable, what can you return? Does that mean you're writing an iterator with yield return? That's one way. What's another thing to do if you're supposed to return an IEnumerable? Yeah?
You can return any object that implements.
Right. You can return an object of any class that implements IEnumerables. So you can return a set. You can return a list. So it doesn't mean when you see returns IEnumerable, it may, all you can assume about the object is that you can iterate through it. But it may, in fact, be a set. Okay? You need to be familiar with using anonymous methods. Basically lambda expressions. Cooking up a something like this. So what can you say about that method? Yeah.
The value x to return x times itself.
Yeah. Take in an x, you return x times x. Okay. What type does x have to have?
Anything that could be multiplied.
Yeah, anything with a multiplication operator. Usually, it determines what x needs to be in the context. So if you're passing it to a method that's going to apply that to a double, then you know that it has that type. So it just gets a type that makes it consistent with how it's being used. So simple lambdas like this you see all the time. Delegates. So you often pass lambdas when a delegate is required, but basically you can pass any method when one is required, and you certainly had to pass a delegate. In fact, I got a fair amount of questions on PS6 from students wondering what to pass as the lookup delegate to the formula constructor. And of course the answer was you had to build a method to look up the value of a variable in the spreadsheet itself. So that was a learning experience there. Regular expressions are an easy kind of question to make up for a midterm. So you ought to be familiar with simple, basic regular expressions. XML documents, now there's not a lot to say about that. You saw how they're used in the spreadsheet. You should know how to do multitasking. Basically, you can, there's like task.run, and you give it a delegate, and it runs on a separate task. And you should know about how to define hookup and fire events. So declaring an event is one thing. Adding an event handler to it with a plus equal operator, that's called hooking. And then firing it by essentially calling the event, which results in the multicast operation of all the hooked delegates being called. And finally, I think this is finally, we did a little bit of modeling. We talked a bit about UML class diagrams to the point that you ought to be able to read a simple UML class diagram and at least say something about how the classes interrelate with each other. And we're constantly drawing simple stack and heap models. When we want to explain structs, I was drawing stack and heap diagrams. I wanted to explain out and ref parameters, I drew stack and heap diagrams. So I'll tell you how to be better than 50% of students when you draw a stack and heap diagram. Maybe I've done this before. All right, here's the secret. When you draw a stack, you draw it like this, and draw the stack frames on the stack. you wouldn't believe how many people, when they're supposed to draw a stack in a heap, they'll draw a stack frame here, and a stack frame there, and a stack frame there, and then they've got their objects on the heap, and they'll draw one here, and they'll draw one over there, and it's just a bunch of boxes and arrows. If I ask you to draw a stack in a heap, draw the stack as a vertical rectangle and put all the stack frames in it, one after the other, and you'll be ahead of the game. Okay, so what other questions do you have? Yeah.
Do you prefer the stack to be on the bottom or the top?
I mean, in terms of growing?
Yeah.
It's up to you. I know a lot of people draw it growing down because often it does grow down in memory. It makes sense to me to have it grow in that direction. If you want to be explicit, just draw an arrow showing the direction of growth. Yeah?
I remember earlier in the semester we talked about static binding and dynamic binding. I can't really recall what that is.
The difference?
Yeah.
Okay. Whoops. Okay, so you create, let's say, an executable. And it makes use of libraries. So you've got two options. There's static linking, which means when you create the executable, let's say it uses 3 libraries. It'll take library A, all the code for library A, and physically embed it inside your executable. And it'll take all the code for library B, embed it, and the code for library C, and embed it. So now you've got a single unit, self-contained, that you can send around and run anywhere this type of thing can be run. Okay? So that's static linking. Dynamic linking, you create your executable, and it makes use of those same 3 libraries. Well, what it carries with it is just a little bit of information that basically says, okay, I use A, I use B, I use C. When you actually run it, so this is the whole thing. Now when you run it, it has to be on a computer that has those dynamic libraries installed. So in memory, you'll have this thing here in memory. There'll be maybe library A is in memory and library B is in memory. So when the program starts running, when it tries to refer to an item from library A, at that point, it has to stop. The dynamic linker has to figure out where library A actually is, and then execution can continue. Then when it needs to use library B the first time it has to stop and find library B in memory, and then when it tries to use library C, it's not only going to have to stop, it's going to have to load it into memory. So there's a few times where it has to stop and link. And then in the future, every time you refer to something in this library, it's going to be via one level of indirection. It goes essentially go into that block and then go into here. Go into that B block and then go into here. So it's a little bit slower to access the library. Plus there's the runtime overhead of having to do the linking as necessary. But what's the advantage? Yep.
It's faster initially. You don't have to load the entire library in the palm run.
Right. So the memory footprint of the application is smaller. So it gets started up fast. Because it doesn't have to load all the library code this one does. And then there's price to pay along the way. This one takes more memory. Suppose you had 100 applications that all use libraries A, B, and C, and you're running on your computer. You would have 100 copies of these libraries, one per executable in memory. If they all use dynamic linking, you would have one copy of A, B, and C. All these executables would be shared in the library. It makes much more efficient use of memory then. And that's a win when most of the programs are using the same libraries, which is often the case. Yeah?
So if all of the 100 programs that were dynamically linked were doing the same things with A, B, and C, would that actually make it slower, or am I misunderstanding how they would share?
This is read-only code. So all these applications would have their own stack frames and their own variables. They'd just be using this code, but it's read-only, so there's no problem with concurrent access. Everything can be, there's no slowdown there. The only slowdown comes, having to actually establish the link dynamically when necessary. And notice also that maybe the program doesn't use one of these libraries except in exceptional conditions, so it may never even have to be looked at dynamically. Yeah?
Would that only affect it at compilation then? Or does it only affect it, or does it still continue to affect it at runtime?
Oh, it affects it at runtime. Because the result of compiling and linking under static linking, this is what's produced. And versus that. So that's what loads, and at runtime these other links are established. So at runtime these have to be loaded if necessary. But if there are 100 things referencing it, they only get loaded once. And then they sort of have to get tied together with the executable. So that just means that if you take take your spreadsheet program, you can, first of all, you can only run your spreadsheet program somewhere where the common language runtime is installed. Furthermore, the .NET library has to be installed, so all those DLLs it uses are accessible to it. Yes?
If we're uncomfortable with the particular topic we've talked about today, other than going back and looking at the materials we've already gotten, what would you recommend we do to kind of...
Come talk to me, talk to one of the TAs if you need more help with the topic. You know, we're still holding our, at least until the midterm, we'll hold our usual office hours. We'll probably be grading the midterm on Friday, and so probably won't hold at least some of the office hours that we usually do on Friday, because the TAs will be grading. Yeah?
On the first slide, I believe this is in reference to the scope. It says PS1 to PS6.
Yes.
Can we expect questions specific to the assignments that we're doing about implementation?
No, I'm not. No. When I say PS1 through PS6, I mean using, you use various programming techniques, like you use regexes in PS6, and you use lambdas in PS2, and that sort of thing. I'm not going to ask you, what instance variable did you use for formula? I once did ask on the final, I said, what was your partner's name? Not everyone could answer the question. I would get things like, I don't know, but he's like tall and has a beard. Okay? You got a question?
Is there anything you would recommend before class finishes up? Is there any particular topic that you think we should really know?
Any particular topic I think you should know? I don't know what to, I mean, it's easy to, I like to ask questions about, regular expressions, ref and out parameters, yield return. It's just easy to make up questions, so be sure you understand that. Okay, I've lost the class, so I guess it's over.